Good evening, everyone, and thanks to Pydata Berlin for having me. Today, I'll be talking about deepfakes or why I have trust issues. So let's begin. So one thing I've heard, and I'm sure all of you have heard as well, is that a picture is worth 1,000 words. But what if that picture is actually fake? So then what does it say? Turns out it actually says more. And based on whom and where you ask, it could contain a lot of misinformation. So let's look at this picture. And this picture looks very much like a human, but it's completely fake. And it's been generated by an AI program. So if you look at this website called thispersondoesnotexist.com, so like every time you go there, it will generate a fake image. And turns out that there are a ton of these sites. And based on what you like, I'm sure there's something for everyone, starting from this meme does not exist. The startup does not exist, and also for cat fans, this cat does not exist. So, there's where my trust issues, kind of, begin. So let's look at this deepfake, which has been circulated by, it's becoming very popular this month, and it's a deepfake of Tom Cruise.
That's why. Oh. It's a little embarrassing, it reminds me, I was once in Russia, I ran into Gorbachev. He said, Mr. Movie Star, are you nervous? TikTok. You guys cool if I play some sports?
As you can see, like, this is the state
That's why.
In 2021, this is what you can do. But it's not all fun because deepfakes cause a lot of problems. And there was this incident where a journalist was investigating, or rather exposing, a child sex abuse case. And to silence her, they started with the misinformation campaign about some fake tweets. And when she didn't stop, so they launched deepfake porn of her. And that kind of had a very big effect on her, and starting with discrediting her as a journalist, and it ended quite badly. And this is not that uncommon. So you can see a lot of these deepfakes being used to essentially alter public opinion, starting with deepfake of a Belgian premier talking about that climate crisis is imminent and linking that to COVID. And you also have other cases where in India, there was a BJP leader, that is a political party, trying to reach out to their voters in their local language, and the audio was generated, was generated by an AI. And right now, before the entry to use the entry barrier to use deepfake technology was kind of like only experts could use it, let's say, but that has been going down. So we have been seeing the rise of deepfakes as the technical barrier to creating them goes down. So right now, the true estimation is around 100 million plus deepfakes in 2021. And a lot of them have to do with easy to use apps. So there's this very popular app called Reface. You might have heard of it. It actually was trending at one point, it was trending at #1 in entertainment. It also beat TikTok. So it allows you to easily create deepfake videos. And this was a news article which I read yesterday. It was a mother using deepfake to actually frame her daughter's rivals that they were doing, essentially create a fake video of their rivals. So it's, as you can see, it's no longer just being used to defame celebrities or used for political agendas. The next victim could be you or me. So this has probably right now is like the tipping point. So the cost of disinformation annually, as estimated in 2019, it was around 78 billion. And the most alarming thing is that false stories actually reach 6 times faster compared to true stories. So the infiltration, if you launch a deepfake, is much faster. So now let's look at a few types of deepfake. So the first one is face swapping. So what happens is that you have a source face, which is the original, and the target face. And the AI model kind of learns what are the facial features of the source and the target are, and essentially swaps these and creates a superimposition to manipulate a face swap deepfake. And then you have the second type, which is facial reenactment. So what happens is that you have the source video and the target. So you can, like, for example, make facial movements or speak anything you want, and that will kind of be mimicked on the target face. So you could make any person say anything that you want. And this is kind of pretty dangerous, right? You can also have full body deepfakes, where you essentially move the target's entire body to whatever pose you like. And then there's the fourth category, of course, which is audio deepfake, where you can generate an audio which has been mimic a person's voice. So there was this case where a company CEO was, so a deepfake of the company CEO was used to mimic a wire transfer of around $243,000. And this has been a rising problem. So let's look at this video. I'm not going to say to you if this is fake or real. Let's see how you can probably figure this out.
When Mexico sends its people, they're not sending their best. They're not sending you. They're not sending you. They're sending people that have lots of problems, and they're bringing those problems with us. They're bringing drugs. They're bringing crime. They're rapists.
So maybe you know if you've seen this, if it's fake or not, or real. So, and that's, you know, where the trust issue really starts to begin, where you even start to doubt what's a real video and you think probably that's a fake. So it's kind of the liar's dividend that we are.
When Mexico sends its people, they're not sending.
And the trust issues start to increase, and probably like to the moon. So there was this report published by a Republican candidate, and he claimed that the George Floyd's death incident was completely fake and digitally manipulated using deepfake. Now, that's of course false, but it's that just because just because deepfake exists, it kind of puts into jeopardy the entire like a real video might be called as, you know, it's deepfake, it doesn't exist. You probably just created it. So some of the trust issues are like, you know, deepfake can be used to cause fraud, espionage, incite mental or physical harm, like we saw in case of the journalist. And we have been seeing increase in these kind of crimes, particularly against women, where someone says or rather blackmails that a person's deepfake porn might be used. And there are, of course, other aspects to it, like influencing judicial proceedings to the point of actually threatening national integrity and security. So what does the future hold? So now, right now, we have AI generated text. So like there's a very popular model called GPT-3, which can be used to generate any kind of text that you want. And now you have deepfakes to generate any kind of video, or GANs to generate any kind of image. So you essentially have all the tools to generate whatever event you want, and you can do that at scale. And thus you can manipulate opinion and essentially spread misinformation. So how does deepfake work? So one of the most popular approaches used in deepfake is by using something called as autoencoders. So in an autoencoder architecture, there is typically 3 blocks. So one is the encoder, one is the bottleneck, and you have the decoder. So the encoder's job is essentially to encode information like an image, which is a high dimensional representation, into a low representation, or rather encoded, which is stored in the bottleneck. And the decoder decodes that information again to that previous image. So usually the decoder just tries to reconstruct that input. Now with the autoencoders, you can do multiple things. And one of them is you can create fake images or anything you want. So how you can use autoencoders to essentially create deepfakes is that you have this encoder block, which is kind of shared. So we'll actually need two autoencoders for creating deepfakes. So the first part is the top part, which you see is the source image, and the bottom is the target. So the source image is you could be yourself, and the target is that whatever you want to impose, like target person. Let's say you want to swap Donald Trump's image on Alec Baldwin. So Alec Baldwin here is the target, and Donald Trump here is the source. So in this architecture, the encoder is actually the same for both the source and the target. And we have two separate decoders. So for the source input, we going to encode it and again decode it exactly to Donald Trump's image. And for the target, we are going to do the same. And this is what happens in the training part. And when you want to actually generate the let's say a deepfake, what you're going to do is, let's say, use the encoder part for Donald Trump's image and use the decoder part for Alec Baldwin's. So what you have here is that by using like the source from the encoder and the decoder part from the targets, you will essentially kind of swap the faces. Now, this is not exactly like state-of-the-art stuff, because there's a lot of artifacts usually present. And with the previous approach, you would need like pairs of videos. So it would require a lot of training. And you can't exactly use that for like inference or like testing whenever you want. So you would need a lot of data to create someone's deepfake. But technology has been improving since then. So you have this an architecture called as FSCAN, which is kind of subject agnostic. And what that means is that you do not need a pairwise training. So so if you do not have a source and a target video, like a training data of it, so you can still use this, because when you actually want to use this sort of architecture to create your own deepfake, you do not need to gather a lot of data and need pairs of source image and target video. So how does this work is by using something called as the generative adversarial network. And the way it works is that you have two blocks, essentially. One is the generator and another is the discriminator. The generator essentially creates fake images, and the discriminator's job is to try to differentiate between the real images and fake images. And the discriminator does this really well at first, but ultimately the generator actually manages to fool the discriminator into thinking that the fake image is a real image. And by generating these kind of, this sort of a training procedure, we're actually able to create fake images which are very lifelike. Kind of sort of the stuff which you saw in the beginning, where I showed you an image of a fake person. So how does this work in FSCAN? Is that, for example, if you have the source and you have the target, what you calculate first is kind of like landmarks. So these would be guiding face landmarks. So a landmark is essentially what you see on the left over here. And so it contains points to your face, and it picks out like very specific and important features of your face, which can be used to represent. So in this first part, you have these sort of guiding face landmarks, and this will be used to kind of first be passed to a generator to first of all align this source face into sort of the way the target's face is looking at. So the first thing which happens over here is the post correction. And over here, the target's face will be passed to another generator, which kind of separates all these, like separates the various parts of the face. So you have the face separated out, and the other parts of the image will be again separated out, like the hair or a earring or something like that. And then essentially, we'll be kind of using the landmarks which we got to essentially train our generator to essentially make generate images or essentially gets sort of like how the movement of the face is working. So we have multiple images. So if it's a video, we can extract multiple frames, and we'll get a lot of these landmarks. So that's why you have multiple landmarks. And once, and if you interpolate between them, you can get an idea of how to move the source, or rather to move the objects, kind of the source's face in a way the target's face is moving. And once you have that, you can do something called as in painting. So typically, once we have this image, you can see like a lot of parts on this image are kind of not completed. And this is very typical because you will always have partial occlusions. And that can be filled up by an in painting network, which essentially fills up this image by picking up detail from the target face. So whatever missing features are from the source, you can probably pick it up from the target's face and create something and complete this image. And the last part is the blending part, where the source face is really blended well to the target's face to the point of looking like very real lifelike. And this is open source, so you can try this out. It's present in the GitHub repository of the paper, which is called FSGAN. And they also have a Colab notebook, so you can try it out really fast. So let's look at how you can actually spot a fake image. And this will be a manual procedure. So over here, we can see an image. And this was released by North Korea's Central News Agency. And they were trying to show a military exercise where North Korea's hovercrafts were landing on the east coast. So, and over here you can see like they have multiple hovercrafts here, and it's actually a fake image. So over here, if you see this left block, and if you compare it with the right block, you'll see that it looks exactly similar. So this was essentially a copy paste of the of this object over here. And similarly, if you look at a few finer details like this ship, you will notice that there is no wake compared to this ship, where you can see that there's wake. So things of small details, and also like essentially that an image will obviously not violate the laws of physics. You can probably understand that an image is fake. And then there are other things which you can look at, for example, the temperature, the weather data. If the image showcases a particular timestamp, you can probably even see like the sunlight direction where it is coming from. And so the shadows will actually show that. And this is a demonstration of how copy of an object can be copy pasted elsewhere. And over here, you can see that this hovercraft we can copy and again paste it here. And that essentially showcases a lot of military strength, kind of to mislead other countries. But this is something which can't be done right now, because this is kind of, if you see, for example, the first video of which I showed you of Tom Cruise, it's really difficult to detect deepfake. So, but there's a problems, and so we have a solution as well. And the first is that we can use an image-based model. And so you have this input video, you're going to extract that into frames. And then you're going to extract the face from that frame. So if you look at the entire image, it might not convey a lot of information, and it may not be that useful. So if it's a deepfake video, typically the part which is manipulated is the face itself. So it's better to just look at the face. And then you can use face alignment techniques to essentially rotate that face somewhat so that it's always straight. It just helps the classifier And then you're going to pass that to a 2D CNN. A CNN is a neural network architecture specifically suited for image tasks. So you can use an architecture like ResNet or an EfficientNet, and then you can finally make a prediction. And this, so you will get a prediction for every frame in that video. And then you can use some kind of scoring strategy to get your final prediction of the entire video. Then you can also use video-based models. So in the previous approach, we used an image-based, so that we were using 2D CNNs. You can also use a 3D CNN. And what that does is essentially looks at both aspects, which is spatial and temporal. So it kind of processes the entire video at one go. And you can, since it's also looking at the temporal aspect, so if there are artifact disappearing and appearing in the next frame or something like that, small changes can also be caught by the classifier. Now, a deepfake detection challenge was hosted on Kaggle. So it was hosted by Facebook, Amazon, and Microsoft. And one trend was that all the top performing solutions, they didn't use digital forensic methods like sensor noise fingerprints, which can extract a lot of information from image creation. When you create an image, it kind of has a lot of information. But if you, let's say, copy paste an object, which like we saw, it will add its own fingerprint noise, and that can be easily picked up. So for example, we have a real face at the top and a fake face at the bottom. And if you do noise level analysis, since this fake photo has been it's essentially a face swap, the part of the face which was swapped and blended, you can see the noise level analysis will kind of reveal that. And it's the same with error level analysis as well. So this can be kind of used to detect deepfakes as well. So there's this paper called Face X-ray for more general face forgery detection. And the good thing is that you don't need any kind of deepfake data set to begin with. So all it needs is real faces. And it kind of generates fake faces on its own by essentially blending those faces. We talked about landmarks before, and the way it creates its own sort of fake faces is by, it picks up a random image, it will calculate its landmarks, and it will look for, in the data set, will look for its closest pair of image, which also shares similar landmarks, and it just kind of blends those images. And so what happens is that you created this fake image, and you also created the blending mask. So the blending mask is where these two sort of faces got blended, so that you have the background face and the foreground face, and wherever the part of the image, both the images were kind of blended, you get that final mask. And so you have a pair of mask for every fake image that you create. And essentially, if you have a real image, you do not have a face mask. If it's a fake image, you have a face mask. So essentially what you can do is image segmentation. So an image segmentation is essentially splitting an entire frame into and drawing like a sort of an overlay over each and every object which is different from each other. So for example, over here, you can see a human with a type of overlay and a different overlay on vehicles, for example. So since now we have created our own data set, so keep in mind that our own data set, a fake image will have this sort of a blending mask, and a real face won't show any blending mask. So essentially, you're going to try to predict where that image has been blended. And you can do this using a kind of a unit-like architecture, where you have downsampling and an upsampling network. So the final prediction is a fake image if the architecture detects that there is a blending mask. And if it's not a blending mask, if there is no blending mask, it essentially means that the image is real. Then you can also, for example, look at video metadata to essentially detect if a video is fake. And for this approach, you do not need to look at the pixel level. What you instead going to look at is stream descriptors. So every video sort of has some metadata associated with it. And even if some of the metadata tags are missing, you can use something like ffprobe to extract all like metadata possible from the video. So, and once you gather all these metadata, and it contains things like what codec it is using, time base, FPS, whatever codec it is using, audio codec, and so on and so forth. And whenever a video is kind of manipulated, some of these stream descriptors change, and it changes in a way which is not kind of correlated or constant with real videos. So by essentially looking at the stream descriptors, you can detect if a video has been manipulated or not. And another strategy is to look at semantic integrity. And what that means is you're going to look at particular features in an image. So if you're given an image, you can calculate a lot of stuff by looking at its metadata, things like GPS and time. So you know the weather data corresponding to a particular time in a particular GPS location. And you can gather all the weather data from it, like sun angles, temperature, humidity, and weather information. And you can also train a neural network to detect all these things on its own. So just by looking at an image, you want to train a neural network to estimate all these values. So, and then you can compare, can you sort of compare the sun angle calculated by the neural network and the sun angle which the weather data shows. And if there is a difference between these two, you can say that this is a fake. If it is kind of the same, it essentially tells that it's a real image. And the last thing which you can do is sort of an audio analysis. So there is something called a spectrogram. A spectrogram can be generated from raw audio by taking its Fourier transform or wavelet transform or things of that nature. So you have this raw audio signal, and you can calculate its spectrogram, and then kind of train a neural network to detect like fake and real videos just by looking at the spectrogram. So the spectrogram is kind of has very sort of peculiar features when audio is generated by AI. And by looking at these kind of features, you can predict whether the audio is fake or not. So our deepfake detection pipeline at Sentinel particular has been kind of modeled after cybersecurity standard of defense in depth. And so we have multiple kind of neural networks looking at various features, starting from metadata to semantics integrity and like just image and video based methods, and also look at the audio. Now, deepfakes aren't all bad. They have their own good use cases as well, which was kind of why they were invented in the first place. For example, you can bring old memories to life. Over here, you can use an app called Deep Nostalgia, which has been vogue of late. So it kind of animates a picture. You can take like any old photograph you have, and it will sort of animate it, which is kind of really nice. Also, like for example, if you want to hide your digital identity, you can do that. So there was this documentary shot of anonymous survivors of the LGBTQ plus community, and this community was in Chechnya, and they did not want to reveal their identities. So some volunteers appeared, and they kind of some people volunteered to allow their face to be swapped on these faces of the survivors to anonymize them. You also have a lot of interesting use cases in Hollywood, for example. So there was, you can see the screenshot of the film The Irishman. And over here, Robert De Niro and Al Pacino's, faces were kind of de-aged. And typically this requires a lot of, first of all, a lot of money and a very big VFX studio. And this is kind of a bottleneck if an indie producer or a small scale production house wants to do these kind of, apply these kind of VFX technologies. But with deepfakes, this barrier is kind of lowered a lot. So there goes to democratizing Hollywood. And of course, you can improve your virtual interactions by animating your digital avatar. So I generated this avatar from a website called Ready Player Me, and then you can kind of animate this face into the way you want to talk. So it kind of improves your virtual interactions in the age of digitization. And with that, I would like to wrap up my talk. And thank you for coming to my Pydata talk. I'll be taking questions.
Okay. We have one question from Dimitrios. Does the FSCAN generate ships too? No, it's just for the face, right?
Yeah, it's only for faces, so like deepfake.
We have a question from Veli, but I think it's missing some context. How about audio using what data? Can you elaborate on that?
So if you have like audio clippings of real and like fake audio, like you can like train a neural network on it. Like the first step you need to do is to essentially get a spectrogram of that audio clip and then just look at the spectrogram. So that could be done by a neural network.
Great. Any other questions? Oh, yes. Okay, a question from Stephen. Will the detection method you talked about distinguish between deepfake and more cosmetic or artistic changes? Sorry, I'm not sure to understand the question.
Some of the if the data is kind of labeled as a deepfake, it will only like detect if there's a deepfake. So you have like cosmetic changes, it won't be picked up. But if you train a classifier to particularly look at cosmetic changes, then it will be picked up.
We have a question from Adi. Is there a large-scale demand for detecting deepfakes, or other than cases such as Google, Facebook, or the social media?
Yeah, so apart from big companies, there is also like governments and security agencies which need it. So, for example, DARPA, which is the R&D wing of the United States of America, they have they have a lot of funding, and they are trying to detect deepfakes and essentially any kind of video manipulation.
Another question from Fushira. How do you know which portion of a picture frame to check for deepfake?
So the procedure is like you pass in the entire video, and then you can like split that video into frames, and every frame is going to be checked. And now if your question is to deal like which portions of a particular frame that you want to look at, So typically in a deepfake video, the part which is manipulated is the face. So you can just crop out the face, and then you can look at like particular features. So the way you can extract faces from a frame is by sorry, by using some sort of a face detector. So something like MTCNN would work.
Great.
I can see that there's a question if deepfakes are getting harder to detect.
Yeah.
And yes, it is. It's always kind of like a cat and mouse game where the detectors beat the generators, and the generators then again beat the detectors. So we have to improve our detection methods. And as you notice, like we have, like there are a lot of ways how you can detect. So, and if you kind of utilize multiple methods, it's kind of gets very hard for the generators to essentially make sure that all of these kind of features are taken into account when they're generating.